All right. So this is where we were last time, and we got into technical issues, difficulties, whatever. Okay. Directed distance is something that we've dealt with for a while, but we haven't called it anything. So when we say that an angle is positive, we mean that it goes in a counterclockwise direction, and a negative angle measurement goes in the clockwise direction. But that doesn't mean that the angle itself is negative, just that it's going in a negative direction. And the same thing with vertical and horizontal measurements. A -4 measurement doesn't mean that the length or the width is negative. It just means that it's moving in a negative direction. So with polar coordinates, we again are going to be thinking about directed distance. So we're going to have first the parts of this system. A pole is what we call the origin. The polar axis lies along the positive x-axis, but you notice there's no negative x-axis and there's no y-axis. The angle theta goes counterclockwise if it's positive, clockwise if it's negative, and we always start at the polar axis. And then r is the distance from the pole to the point. So a point in polar coordinates is labeled r theta. And what's kind of strange with polar form is that you start with theta and then you go out or back or whatever r. So unlike rectangular coordinates where we always start with x and then do y, with polar coordinates, we're going to start with theta and then do r. If r is positive, see, that's Mari. Oh, thanks, Ben.
No problem.
If r is positive, then we're going to start at the pole and go in the direction of theta. If r is negative, we'll start at the pole and go in the direction opposite to theta. And if r is 0, we're going to be on the pole. Theta is a directed angle, just like we said. It starts at the polar axis. If it's positive, it's counterclockwise. If it's negative, it's clockwise, and always it starts at the polar axis. So to plot these points, oh, and polar graph paper is round. I'm going to print out a blank one really fast.
Coffee here.
Sorry, I didn't think to do this before.
No, that's fine.
Thanks, Ben. Okay. Oh, good, it came out big. So to graph in polar form, let's see. The first point that we want to graph is 2 pi over 3. And we're going to start at 2 pi over 3. So let's see, 2 pi over 3. And then we're going to go to the pole. So this is the pole. And we're on this angle 2 pi over 3. And we see that R is 4. So we're going to go out toward 2 pi over 3, 4 units. 1, 2, 3, 4. So that's P1. P2 is -2, -7 pi over 6. So the first thing I need to do is find -7 pi over 6. And I just want to think, where is +7 pi over 6? It's in the third quadrant. So if I'm looking at -7 pi over 6, it'll be in the second quadrant. And of course, it will align with another pi over 6. So do you see we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, but we went in the clockwise direction, so it's negative. So this is equivalent to -7 pi over 6. We go to the pole, and R was -2. Is that right? Yes. R is -2, so we're going to go opposite the pole, opposite the angle. So here's our angle. And we're going to go along this line opposite the angle. So 1, 2. And there's our point P2. Notice that points on a polar grid have many different interpretations. Like we could call P2 -pi/6, 2, because we could go -pi/6 and 2 units toward it. We could also call P2 11 pi/6, +2. We could call P2, well, I don't want to think very hard. So, but do you see that in polar coordinates, each point has many, many different ways it can be expressed? All right, what about 3, -5 pi/4? Well, first we're going to remember that -5 pi/4. Oh, I should see where +5 pi/4 is. Let's see. Oh, here it is. It's in quadrant 3. That means if I'm going backward, it'll be in quadrant 2. And it will line up with the other pi/4 angle. So it's going to line up here with 3 pi/4. We said that R was 3. So we're going to begin at the pole along this line and go toward 3 pi/4, 3 units. P4 is -3, 0. P4, -3, 0. That means that the angle is 0. Well, we start at the polar axis, and we're not going to go up or down. We're just going to stay here. R is -3. That means we're going to go opposite the position of the angle, but on this line, and we're going to go 3 units. So instead of going toward the positive polar axis, we're going to go backward. 1, 2, 3. And then finally we have T5, which is 1, 17 pi over 12. And I did that because this particular polar graph paper, let me see if I can zoom out. This particular polar graph paper is marked off in 12. So let's see, I have 11 pi over 12, 13 pi over 12. Oh, no, 11, 12 pi over 12, 13 pi over 12, 14 pi over 12, 15 pi over 12, 16 pi over 12, 17 pi over 12. So here's our angle. So even weird angles can be pretty easily graphed. And we're going to go 1 unit in the direction of 17 pi over 12. We always start at the pole. So there is P5. Any questions at all about graphing points that are given in polar form? All righty. And let's see if I got it right. Looks good. And I tried to give lots of descriptions of where things are, because this is easy. But if you skip this, the rest can get really complicated. So it's good to get this super solidly down. Well, of course, if we've got 2 different systems of coordinates, we're going to want to go from one to the other. If we're starting with polar and we want to go to rectangular, let's look at a triangle. So here's the pole, here's the polar axis, little r, there's our point, P, r theta. But I know that I can slap on X and Y axes on top of this. And if I do that, I can drop a horizontal down to a perpendicular, down to the polar axis or the positive x-axis. And now I want to call this point PAB. This is polar, r theta is polar, AB or XY will be rectangular. And I know the position of a point in rectangular coordinates. Let's see, the horizontal distance is little a, the vertical distance is little b, because that's how we find a point. But now we have a right triangle with everything filled in, and we can write any of these parts in terms of the others. So I can see pretty easily, let's see, the cosine of theta is adjacent over hypotenuse is little a over r. But I'd like to solve for little a so that if I start in polar coordinates, I can get to rectangular. I'm going to multiply both sides by little r. And we get that little a and or x, however you set it up, will be equal to r times the cosine of theta. And b, well, I know that the sine of theta is opposite over hypotenuse. Opposite is b, hypotenuse is r. If I multiply both sides by little r, I get b, and we see that b, the vertical distance, is r times the sine of theta. So if you start with polar coordinate, you can move to rectangular coordinates by finding the cosine of the angle and multiply by r, and then finding the sine of theta and multiply by r, and that'll give you the x and then the y coordinate. Well, what if we start with A and B? We've got the same triangle. Let's see. So we're given PAB, and we want to find R and theta. What do we know how to find R if we know little a and little b?
Yes.
Yeah, how?
The Pythagorean theorem.
Beautiful. And I'm going to take it a step further. Well, let's see. We know that R squared is a squared plus b squared. I'm going to take the square root of both sides, slap a plus or minus. But what do I know about R?
But it's always going to be positive?
That's right. So here we're not really worrying about the direction of R, but just the magnitude or amount of R. Does that make sense?
Yeah.
Groovy. Now we've got R in terms of A and B. What kind of trig function do we know that involves theta and A and B?
Tangent?
Yeah, good. We know that the tangent of theta is B over A because tangent is opposite over adjacent. And we want theta, we don't want the tangent of theta. So what can I do to both sides to get theta on this left side? What undoes tangent?
I'm
Maybe
not
you like,
entirely
go
sure
ahead.
what the question is.
So what function do we know about that we can apply to tangent that will undo it? What's the opposite of tangent?
Cotangent.
Inverse tangent, is that what you said?
Yeah.
Beautiful. So I can take the arctan or the inverse tangent of both sides, and I get that theta is equal to the arctan of B over A. And this is where I have to be mindful. Arctan is only defined in the first and fourth quadrants. So here theta has to be in either quadrant 1 or quadrant 4. If this is the negative value, B over A is negative, we have to be in quadrant 4, but the point itself may not be in quadrant 4. So quadrant 4 will give us our angle. And then we have to see which quadrant is our point in and how can we move it there. And we'll have an example of that in just a bit. But these are the equations that enable us to go back and forth. If we start with r and theta, we can take the cosine of theta multiplied by r and the sine of theta multiplied by r to get the rectangular coordinate. And if we start with the rectangular coordinates, a and b, we can square them, take the sum, and then the square root will be r. The arctangent of b over a will be theta. And then we just have to look to see, is our point, which quadrant is our point in? So that's basically what I wrote down here with some pretty images. So let's convert this. Justification is just what we did. But let's convert these polar coordinates into rectangular. So, okay, here we've got for PA, we know that R is 2 and theta is negative pi over 3. I know that the x coordinate will be R times the cosine of theta. The y coordinate will be R times the sine of theta. So we'll have 2 times the cosine of negative pi over 3 and 2 times the sine of negative pi over 3. Where is the angle negative pi over 3? Which quadrant?
The fourth quadrant.
Good. It's right here. So what are the coordinates of that point? That's our sine and cosine. Well, in other words, what is the cosine of pi over 3? And what is the sine of pi over 3? And then we'll just have to correct for SIGNs. So what is the cosine of pi over 3? Maybe 1/2? And is cosine positive or negative in quadrant 4?
Positive.
Good. Is sine positive or negative in quadrant 4?
Negative.
Good. And since cosine of pi over 3 was 1/2, we know that the sine of pi over 3 is square root of 3 over 2, and it'll be negative. So we have 2 times negative square root of 3 over 2. The 2's divide out. And we have negative square root of 3. So P sub A is equal to 1 comma negative square root of 3. And square root of 3 is approximately 1.8. Is that right? I'm going to check. Let's see. 3 square root 1.7. So this is approximately 1 comma 1.7 negative. And what is important is we don't need to be any more accurate than that because our graph paper is not any more accurate than that. In fact, the graph paper is tiny. So we've got 1 comma 1.7, so 1 negative 1.7 will be a point in quadrant 4. And you can see its location using polar coordinates and then also rectangular. For point B, you can see that point B is 3 5 pi over 6. So that means that A is going to be 3 times the cosine of 5 pi over 6. And B will be 3 times the sine of 5 pi over 6. And now we think about the first quadrant. What are the sine and the cosine of pi over 6? Which one is 1/2?
Wait, what are we trying to find?
The coordinates for pi over 6.
It's square root of 3 over 2, comma 1/2.
Good. Our angle is in quadrant. Well, that's Evelyn. Our angle is in quadrant 3 of quadrant 2. In quadrant 2, is sine positive or negative? Well, in quadrant 2, sine stays positive, cosine is negative. That means that the cosine of 5 pi over 6 is negative square root of 3 over 2, and that sine 5 pi over 6 is positive 1/2. And we're multiplying both of those values by 3. So we have little a is 3 times negative square root of 3 over 2. And that little b is 3 times 1/2. So for B, we get 3/2. And for A, we get -3 square root of 3 over 2. Well, I know that 3/2 is 1.5, but I'm not sure at all what 3 square root of 3 over 2 is. So let's see. 3 square root times 3 divided by 2. So it's -2.6. So approximately in rectangular coordinates, point B is -2.6, 1.5. Next one. Point C is -4 pi over 4. What are the sine and the cosine of pi over 4?
Square root of 2 over 2.
Good. So to get little a, we're going to multiply r by the cosine of pi over 4. And little b will be r times the sine of pi over 4. And this is kind of nice because it reduces. So -4 divided by 2 is -2. We get that little a is -2 square root of 2, and little b is the same, -2 square root of 2. And let's see what that is close to. 2 square root times 2, so 2.8. So point C is approximately -2.8, -2.8. And point D. Oh, there it is. -5 -5, -2 pi, -3 pi over 4. So I know that little a is r cosine theta. So -5 cosine of -3 pi over 4. And that little b is r sine theta. Is -5 times the sine of -3 pi over 4. And now I just have to remember where -3 pi over 4 is. Let's find that nice big circle. So +3 pi over 4 is in quadrant 2. That means that -3 pi over 4 will be in quadrant 3. So x and y are negative here. That means the sine and the cosine are negative there. So let's see, I know that cosine of pi over 4 is square root of 2 over 2. So cosine of negative 3 pi over 4 will be negative square root of 2 over 2. So we have negative 5 times negative square root of 2 over 2. And the same for the sine. Negative 5 times negative square root of 2 over 2. And now we just need to estimate. Oh, we've got two negatives though, so both of these end up positive. We have 5 halves square root of 2 and 5 halves square root of 2. And let's see, 5 halves is 2.5. So I have 2.5 times 2 square root is 3.5. And let's look at that one. We said that negative 3 pi over 4 is in quadrant 3, and that r was negative 5. So I'm going to use this line, this pi over 4 line, but I'm not going to go toward 5 pi over 4 or negative 3 pi over 4. I'm going to go the opposite way, and I'm going to go 5 units. So 1, 2, 3, here we go. 1, 2, 3, 4, 5. So this is the point, negative 5, negative 3 pi over 4. And let's see, using rectangular coordinate, about where that would be. We said that both points were approximately 3.5 out. So the A value and the B value. So we get that this point is going to be in the very middle of quadrant 1, because we go at the same amount over as we do up. And do you see that that does coincide with this point? That the two really are in the same place. All right. We have one more, I think. Yes. The point E is 3 comma 3 pi over 2. And that's fun because we don't have one of the sine or cosine is 0. Well, which one is 0, sine or cosine? That's right. So we know that at the top, sine is 1, cosine is 0. At the bottom, sine is negative 1, cosine is still 0. So little a is going to be 3 times cosine 3 pi over 2 which is 0, so little a is 0. Little b will be 3 times the sine of 3 pi over 2, which is 3 times -1 or -3. And do you see that that makes sense? 3 pi over 2 is at the bottom of the unit circle. And we're 3 points out. So we're at 3, and we went 3 pi over 2 around. And then if we're in rectangular coordinates, we go along the negative y-axis 3 units. Best of luck. Oh. And so we do end up in the same place. Okay, let's do the opposite. Let's start with rectangular coordinates and go toward polar. So here, point A, little a is +2, little b is -2, and we can draw a triangle. Let's see, if a is positive and b is negative, we're in quadrant 4. And remind me how we can find r? Yeah, Pythagorean theorem. So we know that r is equal to the square root of a squared plus b squared. Let's see, a squared is 4. B squared is also 4. We get the square root of 8. 8 is 4 times 2. And the square root of 4 is 2. So we get 2 times the square root of 2. And 2 times 2 square root is approximately 2.8. So here r is about 2.8. Now we know that theta is the arctan of b over a. Well, b divided by a, they're the same number but opposite sign. So 2 divided by 2 is 1, and a negative is left. So we've got the arctan of -1. And I remember that tangent, the invertible tangent, is only defined in quadrants 1 and 4. So that -1 must be quadrant 4. And the place where sine and cosine are the same, so that we get a -1, is -pi/4. So this point, little a, will be 2.8, comma, -pi/4. What about the next one? Yep. We've got point B is 3, comma, oh, wrong one. Here we go. Point B, yes, it's showing up, is 2, comma, 2 square root of 3. And so I know that little a is 2, little b is 2 square root of 3. R is equal to the square root of a squared plus b squared. That'll be 2 squared plus 2 square root of 3 squared. Well, 2 squared, that's a 4. This 2 squared is also 4. And square root of 3 squared is 3. So 3 times 4 is 12. Plus 4. Let's write this down. 4 plus 12, which is 16. And the square root of 16 is 4. So here r is 4. And let's see, the tangent of theta is b over a. B is 2 square root of 3. A is 2. So the 2's divide out. We get square root of 3. We must be in quadrant 1 because this is positive. And which angle has a tangent of square root of 3? Well, it's the one where sine is square root of 3 over 2 and cosine is 1/2. And that'll be up at pi over 3. So the point B is also equal to 4 comma pi over 3. Point C is negative 4, 3. Well, that's kind of not horrible. It's a 3, 4, 5 triangle. So I know R is going to be 5. Let's go ahead and write it out. A is little 4, negative 4. B is 3. And I know that 9 plus 16 is 25, and the square root of 25 is 5. To find theta, we want to find the arctan of 3 over, let's see, let's put the negative out front, negative 3 over 4. Three divided by 4 negative. 3 divided by 4 negative. And when we find the arctangent of a negative value, we are always going to land in quadrant 4. So let's see. In degrees, it's negative 36.9. Let's see. But negative 36.9, that's close to negative 30, which is 11 pi over 6. The point is over here in quadrant 2. And so when you see that you have a negative tangent and that the point should be in quadrant 2, not in quadrant 4, then you just take the theta that you found. So here theta was negative 36.9. And then you do 180 minus theta to get the angle in the third quadrant, in the second quadrant. So 180 minus 36.9. Let's see. (180) minus 36.9. We get 143.1. And I'm going to find its position by comparing it with angles that I know. So I know that 2 pi over 3 is 110 because it's 30 plus 90, 120. That 3 pi over 4 is 135. And our angle was 143. So let's see, 5 pi over 6 is 130 plus 30 is 150. So our angle is between 3 pi over 4 and 5 pi over 6, closer to 5 pi over 6. And we said that R was 5. So we have 1, 2, 3, 4, 5. So to get our point in the correct quadrant, we had to take 180 and subtract it. And we can see that this is indeed very close to the point two, comma, 2 square root of 2. Oh, no, we were doing negative 3/4. So negative 3, negative 3, positive 4, negative 3, and then 1, 2, 3, 4. So I get that it should be a little higher, but I'm not at all accurate with all this garbage. But you kind of see how this thing works. And we've got one more. Point D in rectangular coordinate is 3, 0. To find R, we're going to have the square root of 3 squared plus 0 squared. Well, 0 squared is 0. 3 squared is 9, and the square root of 9 is 3. That's kind of groovy. Also, the arctan of B over A. That'll give us theta. Well, 0 divided by any non-zero is 0. Arctan of 0 is 0. So its polar representation is also 3, 0. An angle of 0, and we go out the polar axis 3 units. Let's see where we are. Oh, now we're at the prizes. Okay, which I'll post for y'all to work on. And I'd like to take a 5-minute break, and then we'll come back to complex numbers.
Alrighty.